In an unexpected turn of events, NASA's James Webb Space Telescope has made a remarkable discovery that has astronomers worldwide intrigued. Just a few weeks ago, this telescope uncovered the oldest known galaxy in the universe. However, it has now detected something even more extraordinary: a supermassive black hole speeding away from its galaxy at an astounding rate of 4 million miles per hour. This new finding holds significant implications and has sparked a lot of curiosity among scientists and space enthusiasts about what it could mean for our understanding of the universe. The James Webb Space Telescope was originally launched with the goal of studying the first galaxies formed after the Big Bang, and it has already captured breathtaking images of dying stars and galaxies dating back just a few 100 million years after the Big Bang. We invite you to explore these latest discoveries from the telescope with us. Remember to like and subscribe for more content like this. The recent discovery is challenging our current understanding of black holes. Traditionally, black holes have been considered massive objects that consume everything, including light. However, this particular black hole seems to be doing the opposite. It appears to be generating new young stars along a vast trail. Astronomers have detected a series of newly formed stars trailing behind this black hole, which stretches an incredible 200,000 light-years from its location. Scientists are baffled by this unusual behavior, which differs from what we have typically observed in other black holes. A team led by Professor Peter B., an astronomy expert, recently published their findings in the astrophysical journal Letters. The Hubble Space Telescope also corroborated these observations, supporting the idea that this black hole triggers the creation of stars when it interacts with gas and cools it. We are currently observing the aftermath of this black hole's influence. But that's not all. NASA also made an exciting announcement about the galactic collision known as ARP-220, captured by the James Webb Space Telescope. This massive galactic merger can be observed shining brightly alongside other galaxies in the night sky. When two spiral galaxies merge, they create a phenomenon called ARP-220, which shines particularly brightly in the infrared spectrum, making it an ideal target for the James Webb Space Telescope. ARP-220 is classified as an ultraluminous infrared galaxy, with a luminosity equivalent to 1 trillion suns. By comparison, our own Milky Way galaxy has a luminosity of about 10 billion suns. ARP-220 is located in the Serpent constellation, approximately 250 million light-years away, and is considered the brightest of the 3 closest galactic collisions to Earth. It is also cataloged as object number 220 in the Atlas of Peculiar Galaxies. Around 700 million years ago, 2 spiral galaxies collided, triggering a massive surge of star formation. This collision created a dense region spanning about 5,000 light-years, containing around 200 large star clusters. Surprisingly, this small region holds as much gas as the entire Milky Way. Earlier radio telescope observations revealed approximately 100 remnants of supernovae within a 500 light-year radius. Further research with the Hubble Space Telescope revealed that the 2 parent galaxies are separated by 1,200 light-years, with each galaxy's core surrounded by a rotating ring of star formation emitting intense infrared radiation. Recent images from the James Webb Space Telescope reveal the extraordinary galactic merger, showing faint tidal tails extending from the edges of the collision, which are indicative of the gravitational pull between the 2 galaxies. The red, pink, and orange filaments in the image represent scattered material within ARP-220. Another astonishing discovery that captivated scientists was the identification of ancient galaxies at the very edge of the universe. Initially, there was skepticism about their authenticity, with some speculating that these galaxies might be nearby galaxies in disguise. After sharing their data with other scientists, the James Webb Space Telescope confirmed that these galaxies are indeed real. Thanks to this revolutionary telescope, we can now observe some of the oldest galaxies ever discovered. Astronomers estimate that the light from these galaxies has traveled more than 13.5 billion years to reach Earth, offering us a glimpse into the distant past of the universe. These galaxies were formed when the universe was still young, shedding light on how quickly the first generations of galaxies emerged. Spectral data confirm that these galaxies are at the farthest edge of our view, with some even farther than what we previously believed possible. This discovery is pivotal because it validates one of the core missions of the James Webb Space Telescope, studying the early universe by observing light that has traveled for over 13.5 billion years. The ability to measure extreme redshift sets the James Webb Space Telescope apart, enabling it to observe the infrared spectrum and peer into the formation of the first galaxies. The excitement surrounding this discovery is palpable, as it marks a significant milestone in our exploration of the universe and our understanding of its evolution. This discovery has had a profound impact on our perception of the cosmos, prompting NASA to develop even more powerful telescopes to confirm whether our understanding of the Big Bang is correct. Data from Webb spectrometer and near-infrared camera have revealed that 4 of the 6 primordial galaxies exhibit extreme redshifts, suggesting that Webb is observing them as they existed between 300 million and 500 million years after the Big Bang, during a period when they lacked heavier elements such as carbon. This is surprising, considering the universe's estimated age of 13.8 billion years. The existence of these galaxies forces us to reconsider our understanding of the early universe. These groundbreaking discoveries have sparked concern within the scientific community as they challenge the current cosmological inflation model and the Big Bang theory, which contains several unresolved questions such as the law of thermodynamics and the lack of clarity regarding the cause of the Big Bang itself. Moreover, the James Webb Space Telescope's observations of galaxies nearly as old as the Big Bang raise profound questions about our knowledge of the origin. According to theoretical physicist M. Kaku, the discovery of these ancient galaxies calls into question everything we thought we knew about the universe's inception. These galaxies, once thought to be less developed than the Milky Way, now appear much larger and more advanced than expected for their age. The finding that the James Webb Space Telescope has identified 6 galaxies that formed just 500 million years after the Big Bang and are up to 10 times larger than the Milky Way raises doubts about the accuracy of our current theories regarding the universe's creation. Kaku explained that it typically takes billions of years for a galaxy like the Milky Way to form, so it is puzzling to find such massive young galaxies. This discovery may necessitate a complete rewrite of textbooks on the origins of the universe. The findings from the James Webb Space Telescope continue to challenge what we thought we knew about the Big Bang, leaving scientists at a crossroads. Nevertheless, NASA recently tweeted about a galaxy cluster that is located just 650 million years after the Big Bang, adding yet another fascinating piece to this cosmic puzzle. Astronomers have analyzed the data and concluded that this fledgling cluster is expected to grow significantly, eventually becoming a structure similar to the colossal Coma A656 cluster. The location of this cluster is unique, as it is in a region of accelerated galactic evolution. Thanks to the James Webb Space Telescope, researchers can now measure the velocities of these 7 galaxies with confidence, confirming that they are bound together in a protocluster. To put this in perspective, NASA scientists compared these distant galaxies to small drops of water in different rivers, which will eventually merge to form a powerful river. Clearly, the old theories about the Big Bang no longer seem to align with the latest findings. However, further data from the James Webb Space Telescope may reveal evidence that could either confirm or challenge these new discoveries. The Big Bang may have occurred, but its cause could be something entirely different. In any case, we will have to wait for further discoveries, and the answers might be closer than we think. In an astonishing twist, the James Webb Space Telescope, developed by NASA, has made a groundbreaking discovery that has captured the attention of astronomers and space enthusiasts across the globe. Not long ago, this cutting-edge telescope uncovered the oldest known galaxy in the universe, marking a milestone in our understanding of the cosmos. However, the telescope has gone even further in its capabilities. Recently, it detected a supermassive black hole moving away from its galaxy at an unimaginable speed of 4 million miles per hour. This new finding is incredibly important and has ignited a wave of discussions both among the scientific community and space enthusiasts about how it might alter our understanding of the universe's fundamental workings. The James Webb Space Telescope was launched with a clear mission: to explore the universe's earliest galaxies and to peer into the most distant regions of space. It has already provided us with extraordinary views of dying stars and galaxies that date back only a few 100 million years after the Big Bang. Now, these new discoveries promise even more extraordinary insights. The latest revelation challenges current theories about black holes. Traditionally, black holes are considered to be colossal gravitational wells that draw in everything, including light. They have always been seen as vacuum cleaners of the cosmos, pulling in all matter and light. However, this newly discovered black hole behaves in a completely unexpected way. Instead of pulling in light, it seems to be emitting it. Furthermore, the black hole appears to be creating a trail of young stars along its wake as it moves across the galaxy at incredible speeds. These newborn stars are being formed in a long, extensive path trailing behind the black hole, stretching over 200,000 light-years into space. Scientists are perplexed by this unusual behavior, which sharply contrasts with what has been observed in other black holes. A team of astronomers led by Professor Peter B. recently published their findings on this discovery in the astrophysical journal Letters. These findings have been supported by additional observations from NASA's Hubble Space Telescope, suggesting that this black hole awakens new stars as it interacts with surrounding gas, which cools down and becomes a breeding ground for fresh stellar birth. Essentially, we are now observing the trail of cosmic activity left in the wake of the black hole's path. But that's just one part of the exciting developments. NASA has also made an announcement regarding a fascinating galactic collision known as ARP-220, which was captured by the James Webb Space Telescope. This galactic merger, one of the most spectacular events in the cosmos, can be seen lighting up the night sky, visible alongside other distant galaxies. When two spiral galaxies merge, they create intense bursts of star formation and the phenomenon known as ARP-220. This merger shines brightest in the infrared spectrum, making it an ideal subject for the James Webb Space Telescope, which is especially sensitive to infrared radiation. ARP-220 is categorized as an ultraluminous infrared galaxy, meaning its luminosity exceeds that of an astounding trillion suns. For comparison, our own Milky Way has a luminosity of approximately 10 billion suns. Located in the Serpens constellation, approximately 250 million light-years from Earth, ARP-220 is the brightest of the three closest galactic collisions. It holds the number 220 in the Atlas of Peculiar Galaxies, a catalog dedicated to unusual and unique galactic phenomena. Around 700 million years ago, two spiral galaxies collided, unleashing a massive explosion of star formation in the process. This collision created a dense region about 5,000 light-years across, within which are contained about 200 large star clusters. In an astonishing twist, this compact area holds as much gas as the entire Milky Way galaxy. Prior radio telescope observations had already uncovered around 100 remnants of supernovae in an area just 500 light-years across. Further investigation by the James Webb Space Telescope revealed that the two parent galaxies of ARP-220 are located 1,200 light-years apart, and that each galaxy contains a rotating ring of star formation at its core, which emits intense infrared radiation. The most recent images from the James Webb Space Telescope showcase the extraordinary galactic merger in impressive detail, with faint tidal tails extending outward from the edges of the collision. These tidal tails are the result of the gravitational interaction between the two merging galaxies, which cause massive distortions in the surrounding spacetime. The red, pink, and orange filaments shown in the images represent the scattered material within ARP-220, providing a fascinating glimpse into the chaotic aftermath of this galactic collision.